So in the machining industry, the thought that making parts fast means you're going to be more profitable. But I found in my machining journey that getting parts done sooner and not necessarily faster is what actually grows a company. So in this video, I'm going to show you lots of different tools, hacks, and really concepts that we've used here at Pearson Work Holding to accelerate our production. Let's get started. So let me start by saying that the machining industry is notorious for trying to sell fast machines so that boom, parts get done fast, ASAP. But machining is way less of a sprint and more of a marathon. I've never understood why making parts fast and inefficiently or making bad parts fast is a good thing. So if you're a job shop, it really starts from when you respond to a request for quotation and it ends when the money is in the bank account. So shortening that whole time span is what really puts businesses in high gear. All right, follow me and let's start taking a look around the shop. Okay, so tool tags. Now, there's nothing special about tool tags themselves, but it's the information that we put on the tool tags. Now, on these tags that we label ourselves, we tell the type of tool, basically what it is, an end mill, drill, that type of thing, and what material it's used for, whether it is for ferrous or non-ferrous, and then two critical dimensions, the diameter and the gauge length. Now, a lot of times we don't really think of gauge length. Now, what gauge length is a distance from a line here, and it's a theoretical line. It's not the top of the flange. It's actually right, maybe an 1/8 inch above the flange to the bottom of the tool. Now, once that gauge length is known, that is plugged into the control to tell it how much lower from the spindle gauge length to the bottom of the tool. That known number, you can use that and plug it in, and then you tell the machine the origin or the Z0 plane of your workpiece or your fixture. So if you had a gauge length in your control, a tool gauge length of 0, and you went to Z0, it would take the spindle face and it would bury it onto the Z0 position of your fixture or your part. Obviously, you don't want that. So the tool gauge length offsets it up in Z. That being said, why does that matter? Well, once you go through the trouble of finding the gauge length of a tool, you've already done a lot of work. So by adding a tool tag that travels with the tool, that allows you to set up the same tool at a different machine or the same machine with a tool that's already been touched off at a later date. Now that process alone right there makes it so that you're not redoing work. You've already done the work. Now you've recorded it. Now that work doesn't need to be you're not putting yourself in a redundant position. And this is how you get overall setup time to be reduced. Tool tags, super simple. We make these labels on our Dymo label printer or on our tool presetter that just prints automatically. Carbide drills. Now let's talk about carbide drills. A lot of times people stay away from them because they're very pricey. But when you look at the value of a carbide drill, you may find that it's not only less expensive, but you don't have to have as much inventory. For example, this 3/8 diameter carbide drill was close to, if I remember correctly, around $90. Now, a standard length jobber drill is like $9, something like that. Maybe we don't really use high-speed steel around here, but we have some older stub length cobalt drills, which is kind of like a nice in-between thing. Those run in the teens. But when you look at the feeds and speeds of some of these high-performing carbide drills, this in particular is a 3 flute from Kyocera, which is our go-to brand for carbide drills. you'll find that some of the feeds and speeds are double-digit multiples at which you can create holes. For example, we have a 14.5 millimeter non-coolant through carbide drill that drills a hole in one shot as if you needed through the spindle coolant, high pressure coolant, all those things. It just goes in and out, and the cost per hole has plummeted. Now that drill was about $150 to $200. The reason I don't remember is because we bought it about 4 years ago and we've never once had to replace it. I think we have one as a backup, but it's still in its case. So when you look at the value that in a very expensive carbide drill brings, it's actually way cheaper and a lot faster, which is why we're naming it another speed hack. All right, I'm gonna give you two in this tip. Now, number one is add another axis. So when you're talking about multi-axis machining, that fourth or fifth axis, what it actually does is it causes operators to not have to handle the part as much. Now, less handling means you take out the human factor of loading the part correctly. So clamp once and you're machining on multiple sides is a huge win. Now, again, there is a cost to this. It'd probably be like on the low end, maybe 10 grand. On the high end, like we have a TRT 210, which is a 5-axis add-on, and it was around $40,000. But it took us from 3-axis parts to 5-axis parts, and that allowed us to have almost finished multi-sided parts with just high quality standards. Now, the second part of this is better work holding. Just because you have another axis available doesn't mean that it instantly starts to pay you back. So here's a shameless plug because we believe in it and we use it, and that's why we brought it to market. A plug for our RotoVice. Not only do you have multi-axis work holding, but you have 4 parts plus the ability to palletize so that you can go more than 4 parts on each production run or each face of the RotoVice. Now, you're probably wondering, what the heck is this thing doing? Well, we've mounted our Haas rotor unit to one of our Pearson pallets, and then we can hoist it out of the way or drop it in and drop it onto our PPS base when we need to use it. So when it goes to doing setups, we know the origin of this rotor unit. It's actually the center of rotation. When we pop it on the pallet, we just reference that origin of rotation. It's kind of a third tip, isn't it? Standardized origins. So let's talk about why standard origins are a really powerful speed boost. Now, normally when you're machining, you'll take the corner of a part and you'll probe X, Y, and then the top of the part will be Z. That's more of a conventional approach. But with standardized origins, especially with our products like the RotoVice, our pallet systems, you want to mount that work holding in the machine and then probe one time. For example, the PPS base in this UMC 500, we pick up the XY origin at the center of the round pin, and then the Z origin at the top of any one of these 4 pads. Now, what that does is it gives you an origin that's saved kind of permanently. Don't put it in G54. We put it in, for example, G154, P18 for all of our PPS bases. So that way we build it up accurately in our CAD CAM system, especially like in Fusion. We have an exact representation of whatever type of work holding we put on top, whether it's palletized high density work holding, which we also recommend, or if it's a larger part, so you want to use a vise, or maybe some combination of different things that you can customize to the tops of our pallets. Now on our RotoVice, I've said in other videos, you want to pick up the center of rotation as basically your Y and Z center of rotation, where Y and Z planes meet up, that's a line. And then the right-hand side of the RotoVice where you can actually probe and touch as your X, and then program everything off of that. Now, this is super important because when you establish standardized origins, those live in the machine and they don't have to change. We're to the point these days that when we go to make a new product, component, even if it's a new file, we're pretty confident that we just locate off of our known origins, program it, and we don't ever have to probe or pick up edges or anything like that again. Now, this next tip is a big picture tip. It's about wasted motion. Now, most of the motion that we do as we work is really wasted. It doesn't add a lot of value. Now, some shops, they think, oh, let's put things closer. Well, that's part of it. But this next tip is kind of a shout out to Ryan Tierney at Lean Made Simple. Great YouTube channel, check it out. But Ryan recently talked about reducing the waste of motion by first reducing your feet movement, where you travel, your hand movement, where your hands reach, and then eye movement, where you're looking. So in this case, we've gotten pretty efficient around here at reducing our foot movement because it's the most obvious by far. But then when it comes to hands, we found that we were reaching for like no-go, no-go gauges, things like that. And then we found that we were stumbling into a, I don't know, kind of like a sister waste, which was defects when we picked up the wrong ones. So one speed boost is to obviously clear the area of things that are not right. But another thing was that we had these gauges that you can gauge the diameter of a thread. It's basically an OD thread gauge. And they're usually individually placed. And you have to handle them, you pick them up, put them down. But we just did a two-color combined print where we check it, the go and no-go. So our hands aren't having to pick one up, put one down, do that over and over. It's just one type of hand. That's why these are so popular. So it's not like we're saying we're really smart, we invented this. It's the same concept of that. But for an easy speed boost, just keep an eye out on how many times you're picking up and putting things down. Okay, so this next tip applies to shops with multiple machines. Now, one of the things we changed is a lean concept known as one-piece flow, and it was tremendously powerful. So the old mentality was one machine will be dedicated to one entire job, meaning op 1, 2, 3, etc. The adjacent machine, a different job. But with one-piece flow, we switched from having one machine just do op 1 and an adjacent machine do op 2. Now, this does a couple things. First of all, once op 1 is being run, now we can focus on setting up op 2 while we're making good op 1 parts. Then when we get to op 2, maybe we have a short run, maybe 10, 15 parts. We can actually go to op 2 and then see, oh, wait a minute, was op 1 good? We can catch things earlier. And also, the big thing with one-piece flow is it keeps parts from just sitting around waiting, which is one of the 8 wastes. So instead of doing 100 parts op 1 and 99 of them sitting on a bench, you can actually do op 1, and then when op 2 is set up, you can start doing op 2, and then they'll be done. So then parts are going from raw material, op 1, op 2, finished state, or of course, if there's a third op, most likely you'll have to flow it back the other way or to a third machine. But this concept alone, it dramatically increased our throughput and ultimately our speed around the shop. So speaking of reaching for things, reducing that, here we are at our load station at the EC400. And notice Haas has provided kind of a tool tray over here. Well, we reconfigured it. For example, we removed the default tray, air gun holder, that type of thing. And we moved it so it's right here. We've got these holsters from FastCap with 3D printed adapters. Now, why would we have 2? Well, we have 2 because oftentimes there may be 2 different types of fasteners that we have to deal with at a load station. So not every tombstone uses the same fixture. That's just the beauty of a horizontal machine. You can have different jobs running at the exact same time. The other thing is torque wrenches. Now, most people say, yeah, you just get your torque wrench, you set it, you're good to go. But what we found is that there was a potential for a defect, which ultimately slows things way down when you have to fix things that aren't working or are broken or have to make more of good parts to replace bad parts. Torque wrenches took, again, the human factor out of the equation. So every time we torque tighten a fixture or a clamp or a vise, something like that, we knew it went to the right amount. Now, again, because we have different fixtures, for every fixture that we might have, we have multiple torque wrenches. Now here's the second part of this tip. All of this is made possible, including, you can't really see it on camera, but a lot of positional gauges when we're working to position our part, like on our PPS fixtures. None of this could be made possible if we didn't have a robust kind of like mini army of 3D printers. Now we have 4 3D printers in the company, and most days, at least 1 or 2 are printing simultaneously. So could some of these things be purchased? Like, is there a torque wrench holder or hook that you could buy off Amazon? Yes, but keep in mind that Pearson Work Holding has a continual improvement mindset. So if my guys are in between cycles or all machines are running as they are right now, they will hop on and they get to unleash their creativity and create all these little types of mini fixtures and tools that you see all around our shop, print them, and within about an hour or so, we get to test them and put them into the production stream, which continues to speed things up. Well, speaking of 3D printed tools, this is known as the honeycomb storage wall system, which my guy Elliot found online, started printing it, and it's a system that bolts right to a wall, and then all these little like nifty little things that go into it. Now, remember when I told you that you want to reduce your foot movement, then your hand movement? This is our RotoVice build station. All the tools that we need to build are right here at hand's length. Now, I also like it because printing on black and then orange is just a really quick visual indicator. You can move it around. It's super flexible. And then over time, you'll get used to it where you don't even need to look. You don't even need to use your eyes. You can be building and reach up and grab these items once you get that muscle memory in place. Now, when it comes to actually speeding things up, like measurable ones, you can see a lot of data in your CAM system. Now, this tip is called Machine Both Ways, and it's a setting in Fusion which allows you to climb and conventionally cut. Now, quick explanation if you haven't heard of this. A climb cut is when the cutter is spinning clockwise, well, they all spin clockwise, and your workpiece is on the right of it. So it's climbing up the workpiece. Conventional is it's spinning and it's going against it. So the teeth are coming into the cut. Now, the difference there is really about the era of machining. So all cuts up through until we had anti-backlash ball screws were conventional cuts because you wanted to push the cutter, keep tension on the ball screw to push it into the cut. If you tried to climb, you would get this chatter, this jitter as you're pushing the part, or actually pulling the part towards you, and then the cutter would enter the cut and it would pull the part even more. It would hit the end of the backlash and you'd have terrible looking cuts. Well, of course, modern machines are backlash compensating or zero backlash type of ball screws, so this is not an issue. But ditching the conventional cut altogether is not great. So Fusion and the team at Autodesk has made it an option. So I'll just play it here as I talk, and you can see it go in the background. It cuts, and then it cuts both ways. Now, when you're doing it this way, a climb cut is superior because it's getting a big chunk of material, and that's the biggest cut. And as the cutter is into the cut, it kind of peels away and it thins it. Instead, if you're trying to enter a cut and it's trying to increase the thickness of the chip, there's lots of rubbing, lots of heat. It's not good. So you either have to increase your feed rate when you're doing a conventional cut to like get into the material, a thicker portion sooner, or slow down the spindle speed. Well, you don't want to always be slowing down the spindle speed in the middle of your cut. You want to keep some even engagement and a normal sense of rhythm as far as RPMs. So Fusion lets you allow both, but not all materials respond well to cutting both ways. For example, 300 series of stainless steels, you should not ever do a conventional cut because that rubbing creates a heat effect, not a heat affected zone, but you can actually get some work hardening. When metals are deformed, they tend to work harden, so that conventional cut trying to carve into it often will deflect the material slightly until it bites, and it's biting into then a soft piece of material, but then the next tooth is now trying to bite into a hardened piece of the material. So it's really effective when you have large travel distances, such as this one, where we're moving about 10 inches across the part. It's able to cut both ways instead of cutting climb cut, wrap it up and over, climb cut, wrap it up and over. It's making use of that lost travel time, that really wasted motion. So check it out. You can do you can turn the capability on and off in a checkbox, and then you can actually go into Fusion. You can right click and go to machining time, and you get a machining time and see which one is best. It's one of the most simple speed hacks you can do right at your desk. So you remember how I started this video saying that it starts when you respond to an RFQ and it ends when the money is in your account? Now, for years when I did contract manufacturing, like job shop work, it was a point of massive frustration when my customer would push for me to get parts done. I would deliver, and then they would just wait and wait and wait to pay. And especially if a customer had net 30 terms and they're going out to 40, 50, 60 days, it just like internally wrecked me. So nowadays we are a product-based company. So credit card, you can purchase our products direct from us, not through a distributor. It's just direct. You give us the money, it's in our account, it ships same day. Like, that's the type of business model I think all companies should move towards. But what about those legacy customers that are used to net 30 terms? So the solution in us getting our money in our bank account and then the customer getting 30, 40, 50 days to pay, we push that on to a credit provider. Now, I don't do paid endorsements. I don't sell my opinion. You guys know that. But when I looked around, we found a company by the name of Credit Key. Maybe you've seen that on different websites. Another one will be Klarna with a K. These are companies that go through the process of approving customers, setting them up with your company, and then they handle all the, not just the credit, but also the collections. I don't know about you, but for me, I didn't get into machining so that I could be a bank, a lender, and a collection agency. So this has been something that when customers want net 30 terms, we push them towards our provider. We get the money in our account in just a few days. And by then, with just maybe depending on their location, they already received our product, and then they can pay, slow pay, as long as they want. That problem no longer becomes our problem. It's part of our credit provider. Now, when it comes to speeding things up, obviously I have to talk about speeds and feeds. So here's what I've found in my machining journey. When I was a new machinist, I was super fearful of breaking tools, throwing apart, just having chaos occur. So I typically started with the slowest feeds and speeds. But today there is so much proven data, not just theoretical data that you get out of the Machinery's Handbook, but proven data from a lot of the manufacturers. Now, around here, we use helical tool almost exclusively. I'd say about 70% of our tools are helical tools. And for example, they have a feeds and speeds chart. Now, these are good, these are familiar, but Helical also has a Machining Advisor Pro that tells you the type, that actually asks the type of cut you're trying to take, whether it's facing, shoulder work up against the side, or like high efficiency milling, high speed machining, that type of thing, which actually does require close to maximum spindle speeds and multiples of traditional feed rates, because your tool engagement is thinner than conventional cuts, or conventional thinking, and which you need to actually, quadruple, sometimes 10 times faster than Jay of 20 years ago would push a tool. So if I was like, hey, I'm just gonna keep it at 30 inches per minute, this is gonna tell me to move it closer to 300 to 400 inches a minute to get that total material removal rate up. So when it comes to this, yes, I just gave you those 2 tools, but most of these give you a range, like a starting range. If you want to push the speed boundaries, always start at the highest, especially when you're cutting into work hardening materials, a pH stainless steels. They do not like to be cut slowly because they will work harden. You have to take aggressive, fast cuts. Now, when it comes to aluminum, good secure work holding, plus a robust spindle, both in its accuracy and its stability, that type of thing, you can push it to the end. You're not gonna ever break an aluminum tool by taking the maximum recommended feeds and speeds. It's just not a thing. Like carbide and aluminum is no match for carbide. We have some tools that are like maybe 10 years in use, and they still cut to great dimensions. Of course, at this point, they're roughers. New tools start out their life as finishers. But starting with the recommended feeds and speeds at the maximum is a hands down easy speed boost. So go for it. Okay, for my final speed boost, I'm a little nervous about this, but it has to be said. I would say stop chasing tenths and mirror finishes. Now, when I first got onto Instagram as a machinist, it was about 2013, 14, 15, maybe 2016. But I gotta tell you, like, mirror finishes and like seeing indicators on zero was like the thing to post. But when it comes to actually speeding up production, if you have a part print that says the tolerances are ±5, just chase ±5. Now there is one exception to this. On first operation work, if you can get as close to zero with your cutter comp and your offsets, that will only serve you down the road if you do second, third, or fourth operations. Now the reason I say that is, let's say you're cutting a square or rectangular profile to a part. When you go to put that into your second operation work holding, a lot of times that will be work origin located off of the corner of that part. If you're plus 4 thou, 8 tenths, yes, you're technically within tolerance, but your part just got shifted by 2 thou, 4 tenths out of position. So it's a trickle down effect that will throw off follow-up operations. Now, when it comes to surface finish, yeah, we all want beautiful surface finishes. When we used to farm out parts, our prints, literally to this day, say no hand finishing like abrasive pads. It's gotta be machine finish only. That's a note on our drawings. Now, that's because it just kind of communicates a professionalism that a great machinist made this, and he didn't have to like chase any chamfers or edges or scuff up a witness mark with Scotch-Brite. So it's good to chase nice surface finishes, but if the print doesn't call out for a 4 RA finish, it really just slows things down tremendously if you multiply that over dozens or hundreds of parts. Now, I want you to hear this again. Making beautiful, accurate parts is the pride of machinists, but chasing that at the expense of slowing down the total production on a job, on a week, month, annually, or on a career base, a lot of times just isn't worth it. So I talked about the concept of high density work holding. If that piqued your interest, I made a whole playlist of fixture videos called Fixture Friday, and that playlist is right here. If our RotoVice piqued your attention and that seems more of a fit, check out this RotoVice overview video as well. So until next time, go innovate your production.